On your hub, all the activities and what? 2-7 break. Oh, maybe we are on 2-7.
All right, as for today, gonna wrap up chapter 2. All right, then we will have the ability to do all 4 of the first activities. And the last little bit here. So now we lead into graphing, all right? But at least on the one side, it's just one-dimensional graphing, all right? Number line graphing. And I said before, I don't really like go heavy into the set builder notation and everything. My math lab is going to be a little particular about that, so we're going to do them and make sure we know how to do them both ways. Most of the time, I ask questions and say, graph it and show me an interval notation, all right? But we're going to go through all 3 steps. So one-dimensional graphing, all right, just the number line, open interval, we indicate, and I like to draw them above instead of on. So some point A and some point B. An open interval, when you draw that pictorially, we draw that as an open circle to an open circle. That is strict inequalities, less than, greater than, whatever. All right. And with the notation, notice that they're parentheses. As soon as something has the equal to in the inequality, less than or equal to, greater than or equal to, we represent it with a bracket. And on the graph, does anyone know what you represent that with?
Isn't it a line? Solid dot?
Solid dot. The line is that's already there, right? Indicates the start point, the end point. So notice how it all matches up. Bracket to equality with the inequality and solid dot. Parenthesis, open circle, strict inequality. And it always matches up like that. That's the best part about math, all right? It doesn't change every time like English, all right? Once you identify it, it is the same every single time. And similarly, to finish out the concept, all right? That should be, see, that one's close bracket. Point A, closed circle to open circle and closed to closed. Those for any line segment, those are the only 4 possibilities. Now you'll notice when we start solving problems, all right, if it goes on forever, all right, we just indicate with an arrow. We're going to look at some examples. So graph and write in interval notation, and be aware that the set builder notation represented with the open set X, and this is read as X, such that X exists from -5 less than or equal to X less than 2. Again, my math lab's kind of particular, and so if it says set builder, do it in set builder. Truthfully, if you get one of these correct, that's all that I'm really looking for. Graph. And when I draw the graph, you don't have to put all values, -10 to 10. There are two important numbers, all right? 0, and then usually what you're interested, so 2, at least 2. In this case, -5, that's below 0, and 2, oh, look, that's above 0. No, it is not perfectly to scale, but it gets the point. That's what we're trying to identify, all right? We want the concept. Again, I was like, I'm all about the concept. I mean, we got to do the follow through here and there, but the concept is the big part. Over here at the -5, is that an open circle or a closed circle?
That is closed.
Closed. Over at the 2, open circle or closed circle? Open. And then a line connecting. Then I go from -5 to 2. On the -5, is that a parenthesis or a bracket? Bracket. And on the 2, parentheses, right? It all matches up. All right. And that's the point. It all lines up across all 3, basically the picture, all right, interval notation and set builder notation. Totally consistent. That's what we love about it. So the fun part then becomes when we go to solve these problems, sometimes we've got to do a couple steps first. If inequalities follow all the same rules of algebra, except for one big one. When you multiply or divide, and remember division is just multiplying by what that we love.
The number over 1.
A fraction. Yes, 1 over a number, other way, right? But division is just multiplying by a fraction. So anytime you multiply or divide by a negative number, the inequality flips the other direction. That's the biggest rule that you have to remember, right? To make sure you adjust that when you're solving. Now, you can almost always avoid that just by adding and subtracting. If I add it to the other side and bring it back, but since we tend to like our variables on the left side and our numbers on the right side, that rule becomes the big one with inequalities. All right, so we have our little equation here. Other than that rule, everything is the same. In order to solve this first one, what do?
You would get all the x's on one side and all the numbers on the other.
X's on one side, numbers on the other. All right, so
-x -4.
minus x both sides, and what else? -4 both sides. Cancels there, cancels there. 2x minus x is x. Just want to make sure. All right. Again, 2 times x is 2x, right? X times x is x squared, right? Shocking how like what feels like an easy thing, right? Just keep saying that to yourself. Everyone messes that up. Don't feel bad. Okay, the inequality remains, all right, less than or equal to. So it was less than or equal to. That comes down because did I multiply or divide by a negative?
No.
No. All right, then 1 minus 4.
-3.
-3. All right, so for set builder notation, open set x such that, that's what that line means. X is less than or equal to -3, close set. And again, you can kind of simultaneously do the graph and the interval and the set builder all at the same time, or you can step through them, whatever is easiest for you. So the graph, again, 0, and then what other number do I care about? -3. And the only,
+3.
no, -3 is right. The simple concept, but make sure you put it on the right side of the 0. Is that on the right or the left?
Left.
The left, right? If you're not putting all the other numbers, just make sure. I just hate it when everyone's like, oh, I gotta put a 0, and then they put a -3 on the right side, right? Okay, simple stuff. Avoid the easy stuff. All right, then open circle or closed circle at -3.
Closed.
Closed. All right, and then which way, all right? is the line going? Is it going to the right or is it going to the left? To the left. There's a nice trick there, right? And then this goes forever, so typically we just do that and then an arrow. If you always write, okay, with the variable on the left side and the number on the right side, this points in the direction the arrow should be going. Oh, look, it should be going to the left. Now, that only works when the variable is on the left side. So I see people, they write it the other direction and then they make their error. So only in this form. But just as a note, another little hint of, oh, it has to go to the left. All right, and then while we're at it, interval notation. So now we're kind of getting fun. So I got something separated, all right? If the line goes forever to the left, what is the lowest possible number that exists? Negative infinity. Yes, I did hear it. So we start at negative infinity. Negative infinity is always open, parenthesis, because does anyone know why? What is special about infinity? All right, as far as, is infinity a number?
No.
It is both yes and no. When something is both true and false, we call that something.
Nominally.
Oh, close, all right? If you're on a boat and you see a dock on this side and a dock on this side, together we call them what?
Docks.
When I have two of them, kind of like shoes,
A pair.
a pair, but now there's two docks. A paradox. That's that's good stuff. So, yeah, infinity is a paradox. All right, it is both a number and not a number because it is a number in the sense that it is the lowest possible number. But what is that number that we can never identify? All right, so it is always excluding. We go all the way up to -3. And is that one including or excluding?
Excluding.
Okay, we might be messing up including and excluding. Including is when it's closed circle, excluding is when it's open circle. So is this parenthesis or bracket? Let's do that.
It's bracket.
Bracket. Okay, and so there's the three ways we can write it. Just again, practicing, making sure that we can write it all three ways and transition between them seamlessly. Similarly, all right, let's solve this guy. Y less than 16 divided by 8. Gives us y less than 2. Okay, so set builder. And once you've solved the inequality, the set builder notation is pretty simple, right? Because we've done the hard work. X such that, oh, we're doing y though. Y such that y is less than 2. Zero and 2 on the right side, and open circle or closed circle at 2. Open. And what direction are we heading? Left. Again, notice the arrow points that direction. So once again, we start at negative infinity and go all the way to 2, parenthesis or bracket. Parenthesis. All right, everything lines up. Strict inequality, parenthesis, open circle. All right, closed circle, bracket, less than or equal to.
Oh, yes.
All right, let's do one more and then we'll get some fun ones. So this guy, divide by -16. Now finally we're doing what we had warned about. X over here, -64 divided by -16, that is 4. Now that I divided by a negative, it was previously less than or equal to.
That's gonna be greater than or equal to.
Now we have to flip it
Because you divided it, yeah.
because we divided by something particular, not just because we divided on the last one.
Divide by 8.
Divided by a negative.
Negative, yeah.
When you divide it by a negative is when the sign flips. Yep. Okay.
Set builder X such that X is greater than or equal to 4. interval. Now be aware, I can do the interval notation before I make the picture. I just find that making the picture helps with the interval notation a little bit. All right, so 4 is our important number. Open or close circle at 4. Close circle. And which direction are we heading?
Great.
How'd you know it was right?
Use the arrow points.
Oh, the arrow points to the right. All right, the inequality, sorry. The inequality points to the right. All right, it all matches up very, very nicely. So where do we start on this one? Negative infinity again?
No, 4.
No.
Start at 4. Parenthesis or bracket on 4? Bracket. Up to
Infinity.
positive infinity now. Important note. Do not. Let's see, something like this. Oh, infinity to 4, right? Something like that. Okay? Because what's the problem with that one?
Negative.
It's not negative, right? Yeah, like the order in which we are writing this is important. This means we started at 4, including 4, and went all the way up forever to infinity. Okay, same concept with the negatives, right? Negative infinity should never be at on the right of that interval notation. All right, let's do a fun one now. Yes, those other ones were just concept introduction. This is the good stuff. Now it looks complicated, but take a breath. What's the most important thing here?
Rainbow.
Rainbow, 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 right? Okay, where do we start with the rainbow?
On the insides, right?
On the deepest inside. So, all right, I see 6 and I could rainbow that. All right, but that's kind of a pain. All right, so actually let's go a little deeper. How about the 2? And is it just 2?
-2.
Negative 2. Take that negative 2 in, all right? While we're at it, I can actually do 3 rainbows here just because of what's deepest nested. I'm gonna do this 3. I'm gonna rainbow that one in. And I'm gonna do this negative 4. I'm gonna rainbow that one in. Now, again, if you have to do this in slower steps, that's absolutely fine. But none of this is affecting anything further out. So 6. Also simple 4, again, that says 4 minus 2, right, parentheses 6 plus 3t. Remember PEMDAS, your order of operations, rainbow has to deal with the parentheses. That's what rainbow is dealing with. This is additions, all right? Addition, negative, subtraction, same thing, all right? Do not do, way too often people are like, oh, 4 minus 2, and then it's something easier to rainbow, okay? That does. Rainbow happens first. It is one of the most important things to be conducted immediately. All right, so minus 12 minus 6t, important with your signs greater than 5, big bracket, 21 minus 3t minus 32 minus 8t minus 20. So rainbow all those pieces in. All right, just doing a little bit of multiplication there. Nothing crazy. Just happened to do 3 rainbows.
Okay, I did do that right.
Is everyone with me with the signs? The negatives, and remember to take that negative out front. All right, and take that negative. That's why the rainbow goes into both pieces. All right, goes into the first piece and the second piece. Super important. Easy to mess up. This was basically the whole concept of that first activity, right? That first activity is all about making sure you get your rainbow and carry it all through. What should we do now? Should I rainbow again?
Yeah.
Simplify.
Now be aware, I could rainbow, but then I'm rainbowing a lot more terms than I need. So it's always better, let's make it simpler on us before I rainbow again. Because then I get to rainbow smaller numbers if you simplify first. Uh, 11. Now, once I combine a few like terms, all right, again, -3t, -18, -11, then 21 minus 32 again. Use calculator if you need, even we all have to use them sometimes. Then now, see, I have much fewer terms to rainbow. But now we're ready to rainbow again. Once I have that, one more time, what should we do?
So like terms, yeah.
Simplify, and there's not too much to simplify here, but again, every step you simplify, the numbers are already getting kind of like big. So every step you simplify just makes it a little easier on yourself. Does the math still work if you don't simplify? Of course it does. You can do problems 10 different ways, all right? We're trying to do it what's easiest on ourselves as we proceed through. And then, all right, what do we do now?
Plus 48, and plus 55t.
Absolutely. Move the variables to one side, numbers to the other. Our basic two-step algebra. Again, this is, when I get to this point, I want this to be reflex. This becomes muscle memory. All right? These are the parts of the problems that I want you to be like, oh, it's basically solved here. Okay? Okay, 19 and 22, 9, 7.
27,
29.
negative 27.
It's
actually.
negative 29 according to the calculator.
It's negative 27.
Negative 27.
75 minus 48.
Yeah, I was like negative 27. So
Yeah.
That's what I got. Oh.
I was like, wait. I was like, wait. I was like.
Never mind, you guys are right. I just got.
And then last, definitely not least, 19.
Negative 1.42. Oh, that too.
Yeah, I mean, it was like, it's between 1 and 2, right? That's because that's all that matters, because what are we about to do?
Interval.
Yeah, graph and interval. I was like, and convert it to a decimal or not, doesn't really matter to me. Again, my math lab's super particular about fractions.
It is. I figured that.
All right, t such that t is greater than negative 27/19. All right, and again, since I only put the 0, is this on the right side or the left side?
It's on the left.
The left side. And see, look, oh, right there, that's negative 27/19 exactly. And then open circle or closed circle? Open, and are we going left or right?
Right.
Right.
It's always a 50-50 shot, right? Going to the right. And last but definitely not least, we start at parenthesis or bracket, parenthesis. Open, right? All the way up to our
Infinity.
up to infinity, which is what kind of number?
Paradox.
A paradox. Good stuff. Is everyone with me there? As far as the basic concept now, again, this has a little bit more fun beforehand. Same exact concept as these problems though. Set interval graph, solve it down, whatever you get, all right? Put it into those 3 cases, make sure that you can flow between them. Again, and mostly that's because my math lab bounces between set and interval and graph and make the picture, all right? But you should be able to easily do that. I usually like the graph and then I say write it out, and actually barely care if it's in set or interval. If I specify, it always specifies to interval. All right, and then My favorite part, all our favorite parts, second only to fractions,
Word problem.
word problems, all right? Because word problems are how we connect, all right? Gives us context, makes it feel real. So the average price of a movie ticket can be estimated with the following equation, where Y is the year and P is the average price in dollars. For what years will the average price of a movie ticket be at least $6?
I don't know. That's a good question.
That is a good question. I have a feeling we're gonna figure that out. So I have some equation, all right? And then, all right, is there an indication in here that this is an inequality, not just an equal sign?
No.
Nope.
No. Or greater than.
At least, right? If I wanted just a straight equality, it would say equal to $6. But if it says at least, at most, up to, greater than, less than, right? All of those are just subtle ways of saying inequalities. And not subtle, those are the direct ways to say those things. Okay, so, all right, again, translation of English language into mathematics. So we have to pay attention to those types of wordings. So price of a movie ticket represented as P, and I have the $6 amount. So which way, right, is the alligator mouth eating? Is it eating the 6 or is it eating the P?
It needs to be.
Eating the 6?
So. At least less than.
Less than 6 or equal to, right?
Less than 6 or equal to, like that?
No.
Read out what this says. The price of the movie ticket is less than or equal to $6. Is that what at least $6 means?
No.
No, which means it's the other way. And basically, that's all you do in order to turn that sentences, all right, into, all right, something that we can solve. Translate it, all right, write it out, and hey, if you mess up, just make sure you read it. Don't just start solving it. Well, P, we were just given, is that equation, which means then let's put that guy in. And then we can solve away. And again, it does not matter. Everyone's always like, oh my God, the numbers aren't nice. With real problems, there are much fewer nice numbers. It is just a number. All right, that gives us Y greater than or equal to 2001.26. All right, and leaving that as an inequality, there is definitely no graphing here. There's no set build, there's no interval notation. None of that makes any sense in context. What does make sense is maybe a sentence here, because that feels weird how we wrote that, okay? So price of movie ticket was, let's do past tense given a year, was at least $6 from 2001 and 3 months. So 25 years ago, we could get a movie for $6. Oh. And just as an FYI, I could have put 2001.26, but 3 months, right? I'm just estimating quarter of the year. All right, Scott's Electric Company made 17 customer calls last week, 22 calls this week. How many calls must be made in order to maintain an average of at least 20 calls for a 3-week period. We've been seeing this a lot. What does average mean?
All of them added up, divided by
Added,
the
divided
amount.
by 2.
Divided by the number, all right? Can anyone guess why I love averages? You guys remember?
Statistics.
Because I teach statistics, all right? Average is very, very important. And it is a concept I want everyone to understand because it is so crucial to life. You cannot get away from averages. So 17 calls last week, 22 calls this week. How many calls next week? Let's call that one X on average, right? And then something about 20 calls at least. Which way is the inequality facing? Towards the 20? Towards the other way.
Where's the other way?
Towards the other way. All right, because, all right, and this is the concept, right? At least always faces, because it is at least, that is the minimum. It must be a minimum of that number or more. And always think of a simple example, right? You need at least 5 people on a basketball team. That means you need 5 or more. And once you have that, this should be a pretty easy solve. See where we at, 39 plus X. And then what do we do?
So we just, or whatever,
Times by
wouldn't,
3.
Multiply by 3, because what do we love or hate? Fractions. So
that'd be 3/1, right?
almost as soon as you can, right, simplify was the first step at 17 and 22, okay? But then, all right, get rid of that fraction as soon as possible. And then the important part, right, which I definitely saw some mistakes on. On the left side, what happens?
We times it by 3.
Yeah, we did, I know. What happens right now?
It crosses out.
They cancel out. Don't, right? The whole point of that is that goes away. So I have 39 plus X greater than or equal to 60, and easy peasy last step.
1.
So at least 21 calls. Next week, that we're talking about. Next week.
In the 3rd week, I guess you could write it.
Sure. Next week. To maintain. At least a 20 call average. The reason I'm writing sets is once we have inequalities, it just feels weird to say X greater than or equal to 21 calls, right? And it's mostly just because of the context that it sits in. So a sentence is always kind of a nice thing to put here. Is that everything? Oh, easy peasy, look at that. Beautiful. As for today, all right, we have one last activity. All right, there are a total of 4 activities for chapter 2. All right, we now have all the material to cover that. And then all kinds of good news. What are we doing on Thursday?
Yes.
What?
Chapter 3.
Thursday, this Thursday.